What if I told you that the best way to build a really powerful AI model wasn't to train it all the way to completion? A new paper is proposing this pretty radical shortcut that could honestly change everything we know about developing AI and maybe save millions of dollars while we're at it.
So let's just start with the big problem, right? Training one of these top-tier AI models, the ones that power everything we use, it costs a fortune. We're talking millions of dollars, and it can take months of just pure computation. It is an incredibly expensive and time-consuming game.
And that brings us to this wild idea. What if training longer and harder isn't actually the smartest way to do it? What if you could get an even better model by taking a bunch of unfinished versions of it and just mashing them together?
Well, that's exactly the idea we're going to dig into. This technique is called pre-training merging, and it's a huge shift in how we think about the training process itself.
Now, you might have heard of model merging before, but that usually meant taking fully trained models after they were all done and blending their skills. This is completely different. This happens during the training by merging what they call checkpoints, basically snapshots of the model while it's still learning, to speed up the whole process. So the official name for this is pre-trained model averaging, or PMA for short. What they do is they take the model's internal parameters, its weights, which is just everything it's learned so far, from a few different training checkpoints, and they literally just average them together. The hope is you create one single new model that's actually better than any of its unfinished parents.
I know, it sounds almost too simple, doesn't it? Just average them? So let's take a look at the results and see if this thing actually works.
And, well, the evidence is pretty compelling. Just focus on that bar chart up top. The blue bars, that's the merged PMA model. The teal bars are the standard model. In every single test, the blue bar is higher. It's not even close. The merged models just consistently do better.
Now this quote from the paper, this reveals a huge benefit. See, normally you have to use this really complex annealed learning schedule, where you're constantly tweaking the training speed. It's a whole thing. But with PMA, they found they could just use a simple, constant learning rate. Basically, set it and forget it, and get the same amazing results. And this graph right here, this is the money shot. The blue line is that complicated, fine-tuned method. The red line is the super simple, constant rate, but using PMA, and look where they end up, at the exact same peak performance. You're getting the same result for way less work and ultimately way less cost.
But the benefits don't stop there, not with just better performance and efficiency. PMA has another trick up its sleeve, and trust me, it's a big one. It actually makes the whole training process way more stable. You have to understand, AI training can be really fragile. Sometimes a model just goes off the rails, and you get what's called a loss spike. See that huge jump in the graph on the right? That is a catastrophic failure. The model basically forgets everything. That often means you have to scrap the whole thing and start over, wasting weeks of work.
But now look what happens when you use a technique based on PMA. On the right, that black line shows the model just collapsing into that loss spike. But the red line, which is using this new method, sails right past the danger zone. It completely avoids the collapse. So this isn't just about improving the model, it can act like a safety net, literally rescuing it from total failure.
Okay, so we've seen that it works. We know it makes better models, it simplifies training, and it makes everything more stable. But the final question is, why? Why on earth does averaging a bunch of unfinished models create such a powerful result?
This chart actually gives us a really good gut feeling for it. Imagine that dark blue valley is the perfect solution, the sweet spot. Each of those little black dots is one of our unfinished model checkpoints. They're all kind of close, but none of them are perfect. Well, by averaging them all together, you get the red star, which lands right in the middle of that optimal zone.
So, to put it simply, that's the magic. Each checkpoint has learned slightly different things, and it has its own unique errors and quirks. When you average them all together, those random mistakes tend to just cancel each other out, while the stuff it learned correctly gets reinforced. It's kind of like getting the wisdom of a crowd, except the crowd is just the model itself at different points in its own education.
So let's just quickly recap the big takeaways here. Pre-training merging gives you flat-out better performing models. It does this while cutting down on cost and complexity. It also adds this incredible safety net, preventing those catastrophic training failures. It really could be a whole new paradigm for building AI more efficiently.
And all of this leaves us with a really fascinating thought. This research challenges this core assumption that the only way to get a better model is just to throw more data and more training time at it.
If we can get better results by cleverly combining incomplete pieces, it just opens up a whole new way of thinking. You have to wonder, what other elegant, efficient shortcuts are just sitting there waiting to be discovered?